A brand new video. My name is Vikshit. You are watching MathX YouTube channel, and in this video, we'll be discussing a question from JEE Advanced 2025 2015. And this question is based on some properties of fluid mechanics and also some of the properties of LNM, which you can say as Newton laws of motion. So this question is say that a spherical body of radius r consists of a liquid of constant density and is in equilibrium equilibrium under its own pressure, under its own density, under its own density. Now this line, no, its equilibrium under its own density is playing a very great role in this question. And it is said that if P of R is the pressure at R when R is very less than capital R, so the correct option is. So let's first draw the diagram. So let's take, this is the spherical body and it is the center and this is the R, means the radius. Now this whole body is filled up with a liquid. Let's take. So this is the liquid and the density of this liquid, I can take it as rho. There's no problem in it. So there is rho is the density. And it's told us that it is in equilibrium under a constant under its own density. So this line is playing a very important role. Now, what is the meaning of this line? So let's take a point on this fluid. This point is floating in this fluid. Now, for each and every body having a constant mass is having its own gravitational force. So its gravitational, every body is having its gravitational force which is applied towards its center. Okay, towards its center. So this is center and a gravitational force is applied towards the center whose magnitude is we already know as mg. Okay. Now, for taking it is in equilibrium and another force must be applied which opposes the gravitational force. So as the gravitational force is towards the center, the opposing force must be away from the center. So this should be always away from the center. So now the factor, the thing or the concept which is applying this force is what? It's actually the pressure of the fluid. The pressure of this fluid is what? Rho. Then the force will be what? Rho into the area. Let's take it as A. So this is the force. So we can say what? Mg equals to rho A. So this what it's explaining. So by this concept, we can able to apply a very typical concept that is actually required to solve this problem. What we can apply? We can apply the differentiable partial pressure concept. And moreover, only the equation we need in this question. So the equation is differentiable partial pressure concept. It is what? It is dP by dH equals to rho into g. Now what is this g? This g is nothing but the acceleration due to gravity. The acceleration due to gravity is mg and this g. They are the same. Now, first thing, let's leave this equation in a single part and check it out. At the periphery of the circle, means at the circumcenter of the circle, circumference of the circle, the pressure of this liquid, the pressure of the liquid is what? Means if I keep a point on the circumference of the circle, the liquid pressure will be what? 0. Why? Let's draw a tangential line, and this point is over the tangential line, and taking the center as the reference point, draw another line. Now this distance is what? This distance is capital R, which is the liquid column, height of the liquid column. The pressure will be what? Rho h rho g. So height is 0. As the height is 0, the pressure itself is 0. So this is the concept how we can tell it that at the periphery the what you can say the pressure is 0. Okay. Now say me that if I draw a radial line, if this is G1, this is G1 and this is G2, say is G1 is equal to G2 or not? Is G1 is equal to G2 or not? No, G1 will never be equal to G2. Why? Because it's the circumference, because it's a spherical body. If it's another type of body, it may be equal, but as it's a spherical body, it can't be equal. Now, let's come back to the equation. Now, here is a most problematic part is there. This whole partial pressure concept can be only be applied if the G is constant. So as the G itself is not constant, you have to find a particular relationship to make this a partial pressure, means this making this differentiable equation applicable. Okay. Now we already learned that if let's take at the periphery of the circle there is a point. Sorry, at the periphery of the circle there is a point having the gravitational constant as G naught. Okay, G naught. And at r distance from this point, there is another point which is having the gravitational constant as G dash. So, in the gravitational chapter, we had already learned the relationship between this G naught and G dash. It's actually what? G naught equals to, G dash equals to G naught into small r by capital R. Okay, so that's the relationship you already know. So just replace the relationship G by G naught by this whole thing. So this is actually what? This is actually G naught. Now just replace dP by dH. So this H is what? This H is only the R small r. So you can replace it what? As dr equals to rho into G naught small r by capital R. Now arrange this equation in such a way that the constant parts go in one part of the multiplication and the non-constant parts go in another part of the multiplication. So what you can write? dP by dr equals to rho G naught R what you can right, rho G naught by capital R into small r. Okay. Now, as we are going towards the center, so as per sign convention, we will be giving it as a minus. So now take this dr in the right hand part. So what we can write now? dP equals to minus rho G naught by capital R into r dr. Now integrate both these parts. Upon integration, you can see that this whole part is a constant. So this will go outside the integration. It will be integration dP equals to minus rho G naught by capital R integration r dr. Now give the limits of the integration. While giving the limits, make something in your be only concise about only the points which we have to be specific about. Okay, so this is pressure. Now pressure is 0 at what? R, capital R, and let's take pressure is P at small r. Small r. So after integration, what will be getting it? P is equals to, this is as same as the same one, R into small r by capital R. Okay. So this is the relationship between the pressure and the all other things. Now let's check this option one by one, because at this G advanced we have to check each and every option because any of them can be right at this multiple choice option. So at A, P at r equals to 0 is 0. Is it? This, if I take it as 0, is it the whole expression 0? No, never. So this is wrong. Next thing, P at r equals to 3r by 4. So here we have to, here the three options are comparisonal pressure. So for comparison pressure, what we can do? P1 by P2 is equals to what we can write? R1 square minus R square by R2 square minus R square. Okay. Now, if I write here, R1 square is what? 9R square by 16 minus R square by 4R square by 9 minus R square, which will be what? 63 by 80. So this is the correct option. B is the correct one. Let's take the 3, C number option. C is 3r by 5, means 9r square by 25 minus r square by 4r square by 25 minus r square, which will be equals to again 16 by 21. Yeah, it's correct. So C is also correct. And let's check for D. R square by 4 minus r square by r square by 9 minus r square. It will be what? 4 minus 3 square, 3r square, 9 minus 8r square. No, it's not coming. So this is the wrong option. So B and C are the correct options. So this is how we'll be going to be applying all these concepts into a single question and going to be doing it. Okay. So if you are having any problem or any doubt, you can just use the comment section for stating your doubts, or if you have more integral doubts, you can able to just contact me by DMing in my Instagram, which is present in the about section of my channel. So meet you in the next video. Bye bye. Peace out. Bye bye.